as the question says, two blocks of masses m1 and m2 are connected by a spring of spring constant k. The block of mass m2 is given a sharp impulse so that it acquires velocity v0 towards right. Find the velocity of the center of mass. Now, since there is no external force acting on this system of two blocks once this impulse has been applied, so we can conserve the momentum for this system. Now take care, I'm not considering the situation before coming the impulse. I'm taking it just after the impulse and any moment after that. So we can easily conserve momentum over here. So we have the center of mass velocity to be m1 into 0 plus m2 into v0 upon total mass, which is m1 plus m2, giving us the velocity of center of mass to be m2 v0 upon m1 plus m2. Proceeding to the second part of this question, in which we need to find the maximum elongation that the spring will suffer. Now, since the center of mass velocity is m2 v0, whenever the maximum elongation will take place, and suppose at that position both of these move ahead with a velocity of v, because we can write it as m1v plus m2v equals to the initial momentum, that I can write it as m2 v0, giving us the velocity to be m2 v0 upon m1 plus m2. Now the reason why I took the v same for both of these is whenever the maximum elongation will take place, both of these must have the same velocity. So now let us do the energy conservation. We all know that initially when the impulse was applied, then the second block has the velocity of v0. So initial energy is just the kinetic energy of m2 block, and that is half m2 v0 square. And now we have the spring energy due to the maximum elongation, that is half kx square. Moreover, both the blocks will be moving with the velocity of v, and we are having the kinetic energy of half m1 v square plus half m2 v square. Cancelling the factor of half on both the sides and putting the value of v from this to this, we get m2 v0 equals, rather m2 v0 into v0 m1 upon m1 plus m2 equals to kx square, giving us the value of x to be v0 under root m1 m2 upon k m1 plus m2. So this is the maximum elongation that has been asked in the second part of this question. Now this thing you are going to get once you solve this equation.